So far we've talked about congruent figures like segments and angles, and today we're going to get into talking about congruent triangles. What I want you to think about first is back to what congruent meant. Simple definition in my opinion, same shape and same size. So if we're talking congruent triangles, they have to be the same shape, which they're both going to have to be triangles, and then they're going to have to be the same size. Now when we get into the size part, that's going to deal with the corresponding sides. Those are going to have to be congruent. And we're also going to talk about the angles. Those are also going to have to be congruent. Now when I look at that, that means I'm going to have 3 sets of sides that are going to have to be congruent, and I'm going to have 3 sets of angles that will be congruent. Now in my picture that I have here, I have triangle ABC on the left here and triangle XYZ on the right, and I'm saying they're congruent. This right here is referred to as the congruent statement. It's stating that triangle ABC is congruent to triangle XYZ. Very similar to us saying that segment XY would be congruent to segment AB. Now underneath this, and I'm going to get into all this color coordinated stuff here in just a little bit, but under my triangles what I've done is I've shown all the pieces that are congruent. Angle A is congruent to angle X. Angle B is congruent to angle Y, and angle C is congruent to angle Z. Similarly, all the corresponding sides are congruent over here on the right. Now the reason that I know that angle A and angle X are the ones that are congruent come from the congruent statement. Notice that A was the first point in triangle ABC and X was the first point in triangle XYZ. Therefore those are the corresponding vertices, which means then that angle A and angle X have to match up, or those are the corresponding ones that are congruent. Same kind of thing's going to happen here. Point B is the middle, point Y is the middle, therefore those are the corresponding vertices, therefore angle B and angle Y will be congruent. Same thing's going to happen with angle C and angle Z. Now when you go to segments, now I just look at it and I go, well, I can look at A and B together, the first 2 letters of each one, they're going to have to match up with X and Y together, therefore segment AB will be congruent to segment XY. When you can look at segment BC, last 2 letters, segment X or YZ, excuse me, last 2 letters, that would be right here. And then the last set of sides would be, I look at the first letter and the last letter, and then the first letter and the last letter. So segment AC is going to be congruent to segment XZ. And those are the pieces of congruent triangles. Now obviously we can have different triangles. They don't always have to be triangle ABC and triangle XYZ. But just use that congruent statement to help you figure out which angles are going to be congruent and which sides will be congruent. Now I want to look at what's referred to as the congruence transformations. The first one's a slide. And in this one I have this triangle here and I can slide it. Basically keep the original one will be here, the blue one. And then the green one, all I did was I slid it to the right and down a little bit. So this is referred to as a slide congruence transformation. My 2 triangles are congruent, as you can tell when I put them on top of each other. Can't really tell the difference between the 2. But then I can just slide to the right, I could slide to the left and it kind of falls off the page. I could slide it down, I could slide it up. So when you looked at a picture like this, and you had these 2 triangles, the one on the left and the one on the right, you'd refer to this as a slide congruence. Bring us back. We also have the turn, hopefully self-explanatory. Oops, let me try that again. We'll go to the turn now. And on the turn, I have my original and the new one here. And as I do this, it's going to turn it. So if you were to see the blue triangle and the green triangle on a sheet of paper and it asks you which congruence transformation was being used, you'd say it's a turn, because I'm taking the blue one and I'm turning it down to the green one. And it's not always going to turn about a point out here. It might be something like this. So if I bring it back to here, that's where it would start. And notice now it's just turning around a different center point. The last one is the flip. So in the flip, it's going to flip over a line. In this case, I have a horizontal line. My blue triangle is going to flip over it. and it ends up down here. So notice it just totally flipped or reflected over that line. The line doesn't have to be horizontal. Maybe the line's here. It's still going to flip, but now it's going to end up in a different place because the line is moved. And that's referred to as the flip congruence transformation. So we have our congruent triangles, and then we have the congruence transformations when dealing with congruent triangles.